Okay, so here's a more complicated derivative of a natural log, but it's really not that complicated at all. It may be easier than the last one if you watched the last video, because here we're going to apply properties of logs. Um, if you're not familiar with properties of logs or need review, you should definitely do that, because for this one, if you're not going to use properties of logs, you'd have to do u prime over u, which would be the derivative of this over this, which is going to be a complete mess. The derivative of this, what I just circled, is a chain rule as well as a quotient rule, and you do not want to do that if you don't have to. So the first thing I'm going to do is apply properties of natural logs to this to make it a very, very simple problem. So when you have the log of a product or a quotient or something raised to a power, you can use properties of logs. So this is actually a log of something raised to a power because the cube root is 1/3. So the first property of logs I'm going to use is when you do have a log of something raised to a power, you can bring that exponent down. So now I've eliminated that huge chain rule that I would have had to use. But wait, that's not all. Now we have the natural log of a quotient. And whenever you have the natural log of a quotient or a product, natural logs rules still apply, or the properties. So the natural log of a quotient would be the natural log of the numerator minus the natural log of the denominator. So that 1/3 I'm going to leave out as a constant, and then use that property of logs. This would be the natural log of the top minus the natural log of the bottom. So this, just by properties of logs, is equivalent to this. And even though this looks much more compact and simplified, well, when you take the derivative, it's going to be very, very simple with this form. So now I'm ready to take the derivative. Well, the constant rule of differentiation applies. You can ignore that constant 1/3 and just take the derivative of each of these natural logs separately. The derivative of natural log is u prime over u. So for the first one, the derivative is the derivative of x minus 1, 1 over x minus 1. And the second is more or less the same. Let's do that one in purple. Would be the derivative of x plus 1, that's u prime, over u, which is x plus 1. So that's it. We just took the derivative. You could try to get a common denominator and simplify those, but I'm not going to. Normally, you don't even see it done. So that's the derivative. The next video, if you're watching in order, I'm going to take this and I'm going to check it on my graphing calculator. So if you're rusty on checking derivatives on your graphing calculator, make sure you stay tuned for that.